Ever wondered why pushing off the ground sends you gliding smoothly on a skateboard? This isn't magic, but a fundamental principle of physics at work, known as Newton's third law of motion. Think of Jared, a skateboard enthusiast. When he sets off on his skateboard, he applies a force to the ground with his foot. Newton's third law of motion tells us that for every action, there's an equal and opposite reaction. This means that the ground pushes back with an equal force, but in the opposite direction. This reaction force propels Jared forward on his skateboard. In other words, forces always come in pairs. An action force, Jared pushing against the ground, and a reaction force, the ground pushing back against Jared. These forces are equal in strength, but opposite in direction. Now imagine Jared decides to push off the ground with a greater force. According to Newton's third law, the ground will respond with an equal and opposite force. The stronger the push Jared gives, the stronger the push he receives in return, sending him zooming off faster and farther on his skateboard. To sum up, Newton's third law of motion explains why we move forward when we push off the ground while skateboarding. It's all about action and reaction. When you apply a force to another object, that object applies an equal force back, but in the opposite direction. So next time you push off on your skateboard, remember, it's not just skateboarding, it's physics in motion. Equal and opposite forces. The forces involved in actions and reactions can be represented with arrows. The direction of the arrow shows the direction of the force, and the length of the arrow shows how strong the force is. Look at the skateboarders in the figure below. In the top row, the arrows represent the action forces with which the skateboarders push against each other. In the middle row, the arrows represent the reaction forces on the skateboarders. This is the reaction. Compare the arrows for the action and reaction forces. They point in different directions, but they are the same length. This shows that the reaction forces are equal in strength and opposite in direction to the action forces. These skaters are demonstrating Newton's third law of motion, equal and opposite but not balanced action, and reaction forces are always equal and opposite, but they do not cancel out like balanced forces. Balanced forces are equal and opposite forces that act on the same object, so they cancel out and do not result in motion. Action-reaction forces are equal and opposite forces that act on different objects, so they can result in motion. For example, when Jared pushes his skateboard against the ground pushes back on Jared and the skateboard with an equal and opposite force. This causes the skateboard to move forward. Q. Action and reaction forces occur all the time. Can you think of an example in your daily life? A. Here's one example. If you lean on something like a wall or your locker, you're applying force to it. The wall or locker applies an equal and opposite force to you. If it didn't, you would go right through it, or else it would tip over. Watch the video below to learn more about Newton's third law of motion.